And then we use product rule, quotient rule as needed when we have different combinations of trig functions mashed together like these. So example 6, we've got a product, x times sine x. Really no way to do this other than using the product rule, no nicer way than the product rule. It's been a long time. It's been, what, almost an hour since we used the product rule. So it's the first times the derivative of the second plus the second times the derivative of the first. So it's been even longer since we used that dy dx notation. The dy dx, the derivative of y with respect to x, means the same thing as f prime of x. Same thing, it's just different notation. Dy dx equals the first times the derivative of the second plus the second times the derivative of the first. And then we simplify. Well, differentiate and simplify. Dy dx equals x times cosine x plus sine x times 1. I wish I had a real neat, clean way of writing this, but really don't. That's basically it. Dy dx equals x cosine x plus sine x.
Now this isn't something we need to remember, right?
That's right. This is just, remember the derivative of sine x, and then you can calculate this. 2 sine x cosine x. Now this is a, what, double angle formula? Not this, but you could write it as the sine of 2x. We haven't done the chain rule yet. When we do the chain rule, the next section, it will enable us to differentiate sine of 2x, and then we can come back and compare to this. But for now, dy dx equals. Now the 2 you could leave on the extreme outside if you want to, and just deal with sine x cosine x, or it wouldn't be too tough just to associate the 2 with the sine x. I'm going to associate the 2 with the sine x. Either way, we're using the constant multiple rule, but I'm going to think of this as 2 sine x times cosine x. You could do it a little bit differently if you'd want to. I'm going to do it like that. So it's the first times the derivative of the second plus the second times the derivative of the first. There is an extended version of the product rule where it's the product of FGH. And it just gets, it's interesting how it works out, but we usually don't need the souped up version of the product rule, just this, and we can use it repeatedly if necessary. 2 sine x times negative sine x plus cosine x times, and here I have to be a little bit careful, it's the derivative of 2 sine x. So using the constant multiple rule, that would be 2 times whatever the derivative of sine x is. So it's 2 cosine x. Like that. Dy dx equals negative 2 sine squared x plus 2 cosine squared x. And there are various different ways to rewrite that, but we just can't get a sine squared x plus cosine squared x in there. It just doesn't work itself out. You could actually rewrite this in terms of a double angle formula for cosine, but we won't. We'll just leave it like that.
So there's no way you can make it so it be along.
That's right, because they have opposite signs, right? There's a formula for cosine 2x. Cosine 2x equals cosine squared x minus sine squared x. And there are a couple other variations of that. We can make it look like one of those, but we just can't get it to equal 1.